Yeah, okay, so here in section 11.1, the first thing we're going to do is we're going to put the square root over, see how it goes over the left side and over the right side? And up and down the ladder, right? When you put a roof on the house, you got to go up and down the ladder. So it's over the whole left side. It's over the whole right side. The rooting cancels squaring. And now on the right side, what does it mean to have that negative inside the square root? Yeah, remember that? Negative in a root kicks out an I. Now that I comes just to the front of the square root. And then what's the square root of 4? 2. So this will become plus or minus 2i. You can keep the I in the front, but we usually swap them. It doesn't matter. They're multiplied. So I2, 2i, whatever, same thing. They're just times each other. The order of multiplying never matters. So are we good so far? Does everybody see what just happened there? So whenever you have a 2 power, how do you get rid of the 2 power? You root both sides, don't you? When you root both sides, it cancels out the 2 power. But when you put a root over a negative inside kicks an I outside. And the square root of 4 is 2. And you got it when you put a roof on the house, you got to go up and down the ladder, plus or minus. Last step to get x alone? Just jump that 9 over, add the 9. So it becomes positive 9 plus or minus 2i. Those are complex imaginary answers, huh? We good? Questions on that? All right, try that one. Can you solve for x there? Yeah, this one you can. Exactly. Yeah, good. Exactly. So here, so first off, put a roof on the house, up and down the ladder, rooting cancels squaring. So x minus 1 plus, and what's the square root of 9? 3. Yeah, and now same kind of thing, just jump the 1 to the other side. But this one we can go on and finish now, huh? You see what I mean? We can actually do 1 plus 3 and 1 minus 3, huh? So that's 4, and the other one's negative 2. And those are the two answers, and we're done. Yeah, this one you can go on and finish. Why on this one can we finish and not the last one? Yeah, because those are just plain numbers. Whereas the last one, go back here, remember we had like a 9 and then a 2i. We can't add those. Those are unlike terms. Or we had a 3 and a 3 root 2. Again, unlike terms. Everybody seeing the difference? You can only add or subtract like terms. So if one of them is a plain number and the other has an I, those are unlike. They can't be added. Or if one of them is a plain number and the other's got a root, those are unlike. They can't be added. But on this one, it's just 1 and 3, 1 and minus 3. These are both just plain numbers, aren't they? So we go ahead and finish them up. They're like terms. We add them and subtract them, as Maria was saying. That's exactly right. We good there? Hey, by the way, are those the real answers? We can go back and verify it. There was the original question, right? If I go back and I put in the first answer, the 4, does it make it true? What's 4 minus 1? 3 squared?
9.
Yeah, it's working, huh? How about the negative 2? If you put in negative 2 there for x, what's negative 2 minus 1? Negative 3. Squared?
9.
It works. Isn't that beautiful? It's like it just knows what to do. The x can be 4 or negative 2, and it makes it true, doesn't it? These are the two answers that make that equation true. We're finding the truth, aren't we? We're getting to the truth. All right. Okay, so same kind of thing. Go ahead and put the square root over both sides. That cancels out the square. Let me jump in there with you. So first step, square root over this side, over that side, plus or minus. We put a roof in the house, up and down the ladder. So the rooting cancels the squaring, and we have x minus 2/3 equals plus or minus. Now, that square root is over a whole fraction on the right side, huh? Because I had to put it over the whole left side, over the whole right side, over both sides to keep the balance, right? That's always what we're doing in math. So I'm going to put that square root on the top and the bottom, because that's what it really means, doesn't it? A square root that's over an entire fraction is both top and bottom, right? Now, can we leave it that way? Remember, we can never leave roots in the bottom. Did you catch that from the last night's homework? Never leave roots in the bottom. How do I get rid of that root from the bottom? Yeah. Multiply top and bottom by root 3. Remember that last night's homework? Same thing here. So this will become x minus 2/3 is plus or minus on the top. Root 15. What's the bottom? Root 3, root 3? Root 3, root 3. Plane 3, huh? No, I'm doing top, bottom, not left, right. Remember, there's two ways to keep the balance, Claudia. In all of math, there's two ways to keep the balance. You can either do the same thing to the left that I did to the right, which is why I did square root. I did left and right. Or you can do top, bottom. So you don't change that fraction. Both are ways of balance. Both won't change anything. If you do the same thing to the left that you do to the right, you don't change anything. Right? If two things are equal, you treat them the same, they got to be equal afterwards. Or if you do the same thing to the top that you do to the bottom, you don't change anything. So it's okay. I didn't change it. This is just a different form of the same thing, isn't it? Because I did the same thing top and bottom. It just looks different without being different. Good question. And so last step to get x alone. Well, why did I do that? I wanted to get rid of the root from the bottom. We can never have roots in the bottom. So we got rid of the root from the bottom. Last step to get x alone. Jump that over. So x is 2/3. Oops. Plus or minus square root of 15/3. And we're done. Questions I can answer. Is making sense on that then? All right, so on number 8, x squared plus 12x plus 36. Okay. So on number 8, these three, what are we going to do with them? What's that? Yeah. See, the trick on this one is if we factor that, we could do some trick. What am I talking about? How do you factor that? Yeah, you guys are good factorers. X and x, yeah. What two numbers multiply to be 36, add to be 12? What times what's 36? 6 and 6, both plus. That way they'll add to be 12 in the middle, multiply to be 36. And then what do you do when you have identical twins? The same thing twice. Yeah, squared. Right? And then, what do we do now to get rid of that square? Now we root it. See the trick? See how it ends up becoming just like the last one? So we put the roof on the house, up and down the ladder, right? Whenever you put a root on both sides, you got to put plus or minus on the other side. The rooting cancels away the squaring. We get x plus 6 is plus or minus what's square root of 9? 3, and then bump the 6 over. That positive 6, when it jumps over, becomes minus 6. And then, now can we add those? Subtract those? Can we go further? Yeah, those are just plain numbers. Those are not unlike terms, are they? So we can finish those off. We can go minus 6. We can do the two options, the minus 6 plus 3 or minus 6 minus 3. So we get what? Minus 3 or minus 9. They want you to give both answers with a comma, like that. Minus 3, comma, minus 9, either order. Just put a comma between them. How are we doing? Is that good? Yeah, Claudia.
You did it the old-fashioned way where you have to
Get a 0. We would have got the same two answers. Yeah. Now, in a minute, we're going to get to ones that won't work the old-fashioned way. That's why we're developing this. On this one, it would have gone either way. But in a minute, we're going to get ones that only will work with this new way. That's why we're doing it. But good question. Yeah, the old way, you could have got a 0 and factored. Would have got the same two answers. Is this method making sense? You just factor the left side, get a square, and root both sides. All right, let's try it. Okay, same thing, try that one. So go ahead and factor the left side. Okay, so, yeah, so how can two numbers multiply to be positive 64, excuse me, and add to be negative 16? So you got to watch your signs here. So how can two numbers multiply to be positive? There's two ways. It can be 2 positive or 2 negative. Right? Negative times negative is positive. Right? So and that's what we want. We want both negative because that way they add to be negative 16. Are you okay? And I've noticed it's easy to get confused between the signs for adding versus the signs for multiplying. Does everybody know the rules on that? 2 negatives multiply to be positive. They multiply to be positive. Right? The 2 negatives multiply to be positive. But when it comes to adding, just think money. That'd be what I encourage you to do. Just think money. If I said, hey, negative 8, what's that? Is that a gain or a loss? Negative 8. It's a loss, right? I lost $8 and I lost $8. What does that mean for my bank account? Yeah, I lost 16. See, that makes negative 16 in the middle. So adding, subtracting, just think money. Just think money, and you'll know the right signs automatically. Just think money for adding, subtracting. But for multiplying, 2 negatives make a positive. Don't they? 2 negatives make a positive. Good? So, and we got to get them the same. We've got to get a matching pair. They have to be the same. They always will be. That way you can write squared here, because they're the same. If they were different, if it was 1 minus 1 plus, I couldn't say squared. It wouldn't be the same thing twice, would it? They've got to be the same. So, yeah, and now what do we do once we got the square? Roof on the house. And then put the plus or minus right at that moment. The moment you put the root, you put the plus or minus. And so you get y minus 8 is plus or minus square root of 4 is 2. Jump the 8 over. 8 plus or minus 2. So that's 8 plus 2, 8 minus 2. It's 10 and 6. You could check it. It's right. We won't. Questions on that? We good? So there's number 11. So now we're going to try to do the same technique that we've been doing. What's that? Meaning we make the left side factor. But there's only 2 things on the left side. Okay, don't write this down. Let me try some crazy stuff that won't work. I think it's valuable. Before we do the new big thing we're going to do, let me show you that nothing we know so far will work. Let's try it. Don't write this down. Just watch me fail at it. Like, take out an x, for example. That might be an idea. Take out the GCF. Okay, now what? We're trying to get x alone, right? So what would you do now to get x alone? He's in 2 places. Dead end straight. Let's back the car up. That didn't work, huh? That didn't get x alone. What else could we try? Claudia, how about the old method? What was the old method?
Put everything to the left.
Yeah, remember I gave you the whole process? I even said if somebody wakes you up in the middle of the night, says x squared with an equal sign, what should you say first? Get a 0. Well, go back to sleep because that method's not going to work. Those were easier days. Now we're more mature. You're maturing algebraically. Watch me try it. Don't write it down. It won't work. Watch. So they jump that over, right? Get a 0, right? Looks good so far. It's awesome. Well, what's the second step? Factor. You're supposed to factor with the parentheses. Okay. What two numbers multiply to be 10, add to be minus 22? No numbers. What times what's 10? 1 and 10. Can they add to be 20 minus 22? Or 2 and 5? With pluses or minuses or whatever you want to put. No way they're ever going to make 20 minus 22. And neither are 1 and 10. Dead end street. Back up the car. Do you see, that was a cute little method for a while. About real life when they build bridges and they do things with math. That doesn't work. Things don't factor. They were just making nice problems. Maybe they didn't feel so nice to you, but they were. They were nicely designed to factor for you up to now. Now it's time to taste a little more of reality. Real life, things don't factor. So that method, forget about it. Not totally. I'll come back to it. I'll just need to add a patch to it for you. Anyway, but for today, let's set it aside. And let's not move the 10 over. So do you all see that we need something new? The old roads are not going to get us there. We need a new way to get x alone. What we're going to do is what we just did what we've been practicing right here. Now what did we do? We took the left side, which was 3 terms. We're missing a term, aren't we? And then we factored it as the same thing twice, so it would be a square, and then the root took out the square, and we were able to finish. That's what we want to do. But notice, how many terms on the left side? 3 terms. We've only got how many right now? So we need another term. We need to give it another term so that it'll factor. Like the last few we've been doing. Well, how do you know what number to give it? You just put a +1 or 2 or 3 or what do you do? How do you know what number to give it? There's a special rule. Tong, do you already know?
No.
All right. You take the middle number here. Let me write the rule for you. In fact, let me just write it on the board. Have it. Well, I'll write it here too. I'll write the board in a minute. You take the middle number over 2 squared. That's always what you do. That will be the right number. So take the middle number, which is the minus 22, over 2 squared. What's minus 22 divided by 2? Minus 11 squared. Use your calculator. That's positive 121. That's our number. That's what we call the completing number. That'll complete it. That'll give it just what it needs. So you bring this back and you add 121 in there. But if you're going to add 121 to the left side, you have no choice but to also add 121 to the right side because you got to keep the balance, right? If they were equal before you treat them the same, they'll still be equal. If you treat them different, they're not equal anymore. We got to treat them the same. You tracking with me? So now the left side becomes x squared minus 22x. Let me get this out of the way. The left side becomes x squared minus 22x plus 121. The right side is 10 plus 121. So now we do have 3 terms on the left side. And not only 3 terms, but terms that will perfectly factor. It's called completing the square. What we're doing right now is called completing the square. Here you'll see why in just a second. Let's finish this up and it'll make sense. So we're trying to factor right now. What two numbers multiply to be 121, add to be minus 22? What times what's 121? It's 11 times 11, and both are negative. Think about money. If you lose $11 and lose $11, you lost $22, didn't you? And two negatives multiplied to be positive. See how giving it that 121 was just what it needed to factor as the same thing twice, meaning as a square. See how that factors it as a second power, a square. What's on the other side, by the way? 131. Do you see how that 121 gave it just what it needed, completed it, so that it would factor as a square? Which is super great, because once we have a square, we can finish this problem. How do we finish the problem now? Root both sides. When you put a roof on the house, up and down the ladder. So x minus 11 is plus or minus 131. Last step. Jump the 11 over. It's positive 11 plus or minus root of 131. Those are unlike terms. We're done. Can't add them. We're done. There's the answer. We got x alone. See how we were able to get x alone? By this method. Is that making sense? Completing the square. It's like that old saying that you never hear anymore about how your spouse completes you, or your better half. Nobody talks that way anymore. My sweet wife definitely completes me. She's just what I need. And so that's what this number is. It's just what was needed to make it factor as the same thing twice, meaning squared. It completes the square. Gives it just what it needs to factor as a square. That's what this method is. That's what we're doing for the next probably half an hour. There's a bunch of these. They'll get messier and messier. Does that make sense? Questions I can answer? All right, let's try one of these. So try this same process. So let me help you out. Step number 1, take the middle number over 2 squared, add to both sides. So step 1, add that to both sides. And then step 2, factor the left. Step 3, root and plus or minus root. So this is the process. This is the completing the square process. Complete the square. All right, here we go. So, middle number over 2 squared, which is just 1 squared, which is just 1. So I'm going to bring it back and add 1 to both sides, right? Add to both sides. All right. So now the left side, x squared plus 2x plus 1. The right side, 4 and 1. It's just 5. We good so far? Now what are you supposed to do next? That's step 1. Step 2, factor that left side. What multiplies to be 1 adds to be 2. 1 and 1. 1 times 1 is 1. They add to be 2. Both positive. So there it is. I'm factoring the left side. Good? And see how that 1 completed it? Gave it just what it needed to factor as the same thing twice. So that's x plus 1 squared is 5. And then step 3, put the root and the plus or minus root over the sides. Rooting cancels squaring. And last step, bump over the 1, negative 1. Plus or minus square root of 5. How are we doing? That good? So we're able to get x alone using this technique. We wouldn't have been able to do it with the old technique. No questions? How many got it? How are we doing? Okay, that's good. Okay. So here we go again. Same process. So what are we supposed to do? Step 1. Middle number over 2 squared. Add to both sides, right? So what number is the middle number? Yeah. So you take the 1 over 2 squared. Now, you can't divide 1 by 2. What happens when you square it? 1/4, huh? Right? Square the 1, square the 2. 1 squared is 1. 1 times 1 is 1. 2 times 2 is 4. So now what are you supposed to do with that? Add it to both sides. Yeah. So this is a fraction. So you got to add 1/4 to both sides. All right, so then what do we have now? We have x squared plus 1x plus 1/4 is 9 plus 1/4. Right? We good so far? So we added it to both sides. What are we supposed to do in step number 2? Factor the left, huh? Well, how's that? How do you factor this left? What two numbers, x is in the front, what two numbers multiply to be 4/4 and add to be 1? Yeah. Does everybody see it's a half and a half? Half and a half add up to be a whole 1, don't they? And they times to be a 4th. Now, they're going to get even messier than this, and I want to make life easy for you. That is my job here, is to make this tutorial as easy as possible. Let me give you a very important hint, so you don't have to think hard on these, especially when they get really ugly. It's always the number in the parenthesis. Always. So I really encourage you to write it out just like I'm writing it out. Don't do some different thing. Because the method in which I'm writing will really help you. It'll make it flow easily for you. So what I mean is, what do I mean? Write it out like I write it out. See how I put a little arrow? I took this number that was in the middle. I put it on the side. I put parentheses. I put it over 2. And I squared it. And then I came down to another line and I wrote the result. And then I brought it back up. Show exactly that on your papers, on your work. Same thing. Then it'll make it easy, because when it comes to the factoring step, here's the saying that I'll say to remind you. The number in the parenthesis is the number in the parenthesis. Both of them. Plus a half, plus a half. That'll always work. And it's nice. We didn't need it when the numbers were easy, but as they get fractions and even uglier than this one, it'll be nice just to not even have to think about it. The number in the parenthesis will be the factoring number in the parenthesis. Every time. And now, what about the right side? How do you do 9 plus 1/4? Can I write that as a mixed number? Is that the same thing? I mean, is 9 and 1/4, is 9 and 1/4 the same as 9 plus 1/4? What have we learned in math about when you write two things right next to each other, like 9 and 1/4, with no symbol in between? No symbol in between, doesn't it always mean multiply? I just asked you a bad question. But on purpose, though, because I'm trying to teach a lesson. Yeah, it's true. Normally multiplies in between. This is not multiply. It's going to break that old rule. It's actually add. It is add. And then why was the question I asked a bad question? To figure out, suppose you're in the middle of an exam and you're like, I don't remember. Because there's too many, are there not too many rules in math to go around like a math encyclopedia? Remembering on page 703, the rule, that's not the way to do math and science. Not the way. Better is real life understanding. So for me to look at, suppose you're in the middle of the exam, I don't remember, is that the same? I don't remember. Too many rules. Instead of asking the dumb question I asked, what do we always do? What's the math rule? Who cares what the math rule is? Math is all made up anyway, as we've said several times, right? What's real? That's always the best way to, that really is. If I was after 25 years, 26 years, whatever, 27 years of teaching, if somebody, 25, somebody's asked me, one sentence, Mr. Heron, what's the difference between people that seem to get math quicker and less quick? What I've seen after thousands of students is people that get math quicker, it's more real to them. It's real. When they see 9 1/4, they think 9 1/4 pies or something real. They're not just symbols floating on a paper for them. It's real. The more it's real to you, you'll know what to do. You'll know. What if I said to you, just think real life, I said, hey guys, in my trunk in my car, I've got 9 1/4 pies. You know what that means. You don't need me to tell you, well, the math rule says that means. You know what that means. Does that mean I've got 9 pies? Does that mean I have 9 pies times a fourth? No. I've got 9. You think, oh, Mr. Heron has 9/4 of pies. He's got like 9 little 1/4 pies in his trunk. That's what he said. He's got 9 1/4 pies. You say that to anybody on the street, they'd go, are you insane? 9 1/4? What does that mean in my trunk? 9 pies plus a fourth. You know it means plus because you're living in the real world. See how you know the rule if you'll just dial into reality? Try that more and more and more. Make math real. Every time you have a question, think about something real. Remember, math is just made up. They're just trying to fit reality. That's all they're doing. So don't worry about memorizing all these math rules. Think about what's real, and you'll have the right math rule. All right, so yes, the answer is yes. That's a long answer to that question. Yes, 9 plus a fourth. Of course it means 9 1/4. That's what 9 1/4 means. It means you got 9 plus you got a fourth. Yes. And so now why am I saying all that? Because we know how to deal with that, huh? How do we easily change that then? What do? Remember, you multiply the bottom number and add the top. Remember that? 9 times 4 is 36. Add 1. 37/4. We do have to change it to that form. We can't leave it as a mixed. We do have to change it. But mix is real nice. I think, we all know that rule. Just multiply the bottom, add the top. So now, what does the left side become? X plus a half is 37/4. What's step 3? Root and plus or minus root, huh? So let's do that now. Root, and you got to put plus or minus on the right side. Whoops, did I lose the square?
Yeah.
Thanks.
Yeah.
Tongues, probably many of you were thinking.
Yeah.
What's Mr. Heron doing? Yeah, and then that cancels, huh? And so we get x plus a half is plus or minus. Now, we do have a little bit of work to do here. Let me bring it over. I still leave it. What is a square root that's over an entire fraction? 2 square roots. Square root of 37 and square root of 4. Huh. Good so far? A square root over an entire fraction, and I did have to put over the whole right, is a square root on both. I can't square root 37. So it's just going to stay there unrootable. If that's a word. I'm making up new words. It's unrootable. But the bottom, square root of 4, that's just 2. So I'm just going to make that 2. And I'm going to erase the square root completely from the denominator. That's what happens, right? When you root something, it does its root thing and vanishes. So it stays on the top because it couldn't do its root thing. It can't root 37, it's unrootable. But it rooted the bottom, root 4 is 2. That'll always happen on these square completers. The bottom number will always be rootable. It will stay on the top every time. Make sense? Say that again? If I had, good question. If I had the square root of 37 over square root of 2, I don't. I have square root of 4.
Oh, I'm sorry, I mean the 4. I meant the 4.
Right. Yeah, I see what you're saying. Okay, yeah. So, why don't I multiply top and bottom by root 4? Isn't that what we learned to do with square roots in the bottom? It's a really good question. Isn't that what we learned to do with square roots in the bottom? Yes, unless they naturally go away on their own. Square root of 4, what is that? That just becomes 2. So it goes away on its own, and I don't have to do the fancier thing. Yeah, if that was a number that was not rootable, like root of 3 or something that we could not root, then you're right on the money, I would multiply top and bottom by root 3. That would be exactly right. But yeah, if it's a number that roots on its own, just do the root.
Yeah. And even if you do it,
it would work out. It'd be a lot harder.
Yeah,
but it would still come to the same answer. It's not wrong. Yeah, but the quicker way is if it's rootable, just do it. And then we don't have to root the bottom anymore. Yeah, exactly. That good? Last step, boom, just jump over that half, we're done. So just jump over that half, right there. So, and what happens when something jumps to the other side? Sign in front changes, so x is negative a half, plus or minus root 37 over 2. There it is. All right, we good with that? Ready to try one of these harder fraction ones? All right, so look at the way I did left side. I take the number in the middle, put parentheses around it, square, over 2, squared. Do that form, it'll help you. All right, number 13. X squared minus 9x is, okay, 13. X squared minus 9 equals 7. All right, try that one. All right, looks like we're on track. So step 1 is middle number over 2 squared. Add to both sides. So middle number. Now remember, when you take that middle number, take his baby with him, right? Remember, signs in front. That's your baby. You never leave your baby behind. Over 2 squared. Like that. Right? Is that good? And then square that thing, 81/4. Right? Because if you square, now, I could write that out. That means minus 9/2 times minus, that's what the 2 power means. It means 2 of them, huh? And negative times negative is positive, and 9 times 9 is 81, 2 times 2 is 4. Oh, by the way, good question. A couple people ask me. If you were to, this one's different because if you divide 9 by 2, you get a decimal, huh? They don't want decimals in the final answer. So if you ever divide and it's decimal, then forget about it and just leave it as a fraction, and then just go top times top, bottom times bottom, and just keep it as a fraction. They make us do it that way. Whereas like on some of the other ones, like back here, 2 divided by 2, and it just became 1. So yeah, if you can divide them and it's a whole number, great. Do it. If you divide them, it's a fraction. I'm sorry, if it's a decimal, then you got to leave it as a fraction. Okay. So 81/4. So positive. So that's the completing number. And so what do I do with that now? And now notice how I always write this. I really encourage you to follow because it's going to make it easy to finish. All right, I put it on the side, parentheses square, then I square the top, square the bottom. 9 times 9, 81, 2 times 2, 4. And it's by the way, it's always going to be positive. Your completing number is always positive because even if the original one was negative, negative squared is positive. Right? It's squared, so it's always going to be positive. Okay. And what do you do with it? Add to both sides. So bring it back here. Add 81/4. Add 81/4 to both sides, huh? So then what do we have? We have x squared minus 9x plus 81/4 is 7 plus 81/4. So now the left side is guaranteed. Step 2, factor the left side. So factor the left. So the left side is guaranteed to factor. Now this is where it's getting a little ugly. These numbers are fairly ugly, 81/4 and stuff, You don't have to think hard. It's always going to be just x's in the front, plain x, nothing more. And then in the back, remember the rule I'm giving you, the number in the parenthesis, I mean exactly. Same sign, same everything. The number in the parenthesis will be the number in the parentheses with that sign. You don't have to put an extra sign or an extra plus or minus. Just that literal sign. If he's got a negative, take it with him. If he's got nothing, then it's positive. Because nothing is positive. Right? And then the right side, this is a mixed number, as we talked about the pies in the trunk. And then so the left side now is the same thing twice. So that's squared. See how that made it factor as a square perfectly? The right side, you know the deal. You multiply the bottom, add the top. Is it 109 over 4? You keep the same denominator. 109, right? And now last step, well, virtually last step, root and plus or minus, right? Step 3, root and plus or minus root. So I do that, rooting cancels, squaring x minus 9 halves. Now remember, the square root stays on the top, but it goes away on the bottom because you can root the bottom number. Right? You can't square, that'll always happen. The square root just stays on the top, but the bottom number you can square root. Square root 4 is just 2. So the root is gone from the bottom. Last step, just jump over that. Minus 9 halves, right there. So the answer is, it becomes a positive 9 halves when it jumps over, right? Things change. Plus or minus square root of 109 over 2. Is this making sense, this process? Questions I can answer? Exam? Oh, what? By the way, do you notice what's making these harder fraction ones happen? What is it about there? Let's look back for a second. Look at that. That was a harder one. I'm going to give you one harder one on the exam, like this one, just like this one. And then look back here, like this one. This one was a lot easier. No fractions anywhere. Divisible by 2. Is that what you're saying, Vincent? Yeah.
Anything that's like probably divisible by 2 or maybe even number.
Yeah, that's what even means, huh? Divisible by 2. Yeah, if the middle number you see is even, then when you divide it by 2, it's just nice, clean, no fraction. But if the middle number is odd, like the one we just did, see, odd middle number, then you can't divide it by 2. I mean, it stays a fraction, is what I mean. So those are the harder ones. Exam you're going to take in a couple weeks, I'll give you 2 of these. One even, one odd. One easier one harder one. So you just did the hardest one. This is the hardest it's going to get for these kind on the exam in 2 weeks. Be an odd one. There'll be an easy one and a hard one, even one and an odd one. Small thing. You have the process now. The only thing that's different about this one is that 102's in the way. Just pull him to the other side. The rest is the same. That's literally it. Just now see how in the other ones they already had the number on the right for us. We just had 2 things on the left and the number was already on the right. Now they're just saying, hey, what do you do now? Well, just bump it over and the rest is the same. Does that make sense? Just get it out of the way. That 102 is just kind of in there. It's a negative 102 on the other side. You know, things change signs. And now just do the rest the same. Right? Take the middle number over 2, square. Is this going to be an easier one or a harder one? Easy because the middle is even. So you're not going to have to deal with fractions, huh? So go ahead, crank that one out. So I really encourage you, let's take a look. So remember the process I gave you. Follow this every time. It'll help. Take that number in the middle, draw a little arrow off to the side, put that number over 2 parentheses squared. Literally write that. And then if it's even, if you can divide it, divide it. 34 divided by 2 is 17. You see what I mean? If that was an odd number, like, say it was, like 31 over 2, then that'd be a decimal. I wouldn't bother to divide it. But it's 34 over 2, so that can be divided and be clean. 17 squared, 289. Is that good? Then that's what we're going to bring back. We're going to add 289 to both sides. Is that making sense? And now the left side, x squared plus 34x plus 289, and this is 187. And now the left side is gonna factor. X is in the front. How does now, you remember you don't have to work hard. I gave you something that'll always work. If you did my three things on the side here, these three things, the number in the middle, the number in the parentheses is the number in the parentheses. Same sign, same everything. What sign is on this 17? I don't see any sign. Get rid of these. The plus. That is the right factorization. 17 times 17 multiplies to be 289. You can check it on your calculator if you want to. And they add to be 34. That is the right factorization. And then, there's two of them, huh? Last step to get x alone. Well, next step, get rid of the root, plus or minus, rooting cancels squaring. Right, third step, root and plus or minus root. So x plus 17 is plus or minus. I don't think that's rootable. You can check it on your calculator. It doesn't root, huh? Just leave it like that. Bump the 17 over. Negative 17 plus or minus. Whoops, I reversed him. I've got dyslexia. 187. There we go. Good there? How we doing? Is this making good sense? Questions I can answer? How are we doing on time? I probably better get to something else. Questions on that one? All right.